Okay, so now we're going to look at how we can take an equation that's in standard form and rewrite it as vertex form. We saw when we were doing graphing that vertex form, when we get our h and k, makes it really easy and really fast to graph a quadratic. So it's going to be a helpful tool to kind of have in your back pocket whenever you need to graph. If a is not equal to 1, it can get pretty messy. So as far as we're concerned with for this class, we're just going to focus on when a is equal to 1. So here's an example of a problem. Y equals x squared minus 10x plus 22. We want to write that in vertex form and then give the vertex. Now what's different about what we've been doing, in the previous problems that we've been solving, we didn't have this y. It was always equal to something. So that's what's a little bit different here. When we complete the square, the process for this, because of that y, is going to be a little bit different. X squared minus 10x. Now, we're going to have that plus 22. Normally, we would subtract that to the other side, but the other side is y. So I'm not going to be able to combine that with anything. So instead, we're going to do something that's a little bit weird. It's almost like cheating. We're going to take this and split it up after the ax squared plus bx terms. And I'm going to rewrite this now with quite a bit of space in between there. I have x squared minus 10x. Now here's what we're going to do. Instead of completing the square and adding something to both sides, we're going to add it. But since I can't add it to the other side, we're going to immediately subtract it back off, the same exact number. And then we still have that plus 22 over here. Now that's kind of weird. Just bear with me for a second. So let's think about what we would do. We would need half of 10. Half of 10 is 5. 5 squared is 25. So I'm going to do plus 25 minus 25. Now, think about this for just a second. If I have a positive 25 and a negative 25, what does that really equal? It's 0. And remember, we're allowed to add 0 to whatever we want, whenever we want, because it doesn't change anything. So this is kind of a little math trick that we're doing. I need that plus 25 to be able to complete the square, but I'm not allowed to add 25. I am allowed to add 0. This is actually a trick that mathematicians use a lot to do different things, but for us right now, it helps us mainly with our completing the square. So after we add that 25, this is where we're now going to divide up our equation, because what we got here, that is our perfect square. That is what we can factor. I get x minus 5 squared. And then we can combine these like terms. Negative 25 plus 22 is negative 3. So now my new equation in vertex form is y equals x minus 5 squared minus 3. If you were to FOIL that out, the x minus 5 squared, and then subtract 3, you'd get back to that original equation in orange. So what would the vertex be for this particular graph? It's going to be h and k. And remember, you always have to change the sign on h. So since I have a minus 5, it changes to a positive 5. But k you always keep the same. So it's going to be negative 3. Okay, let's look at one more example. Hold on, we've got something going on here. Remind me later. Okay, sorry about that. Here we go. So we want to write y equals x squared plus 6x plus 3 in vertex form, and then identify the vertex. So I have y equals x squared plus 6x plus 3. First thing we're going to do, split this apart. So I'm going to take this out. X squared plus 6x. Now, I'm still going to have that plus 3 at the end. It doesn't go away, but I have to figure out how to complete the square. Half of 6 is 3. 3 squared is 9. So I'm going to add the 9, but I'm also going to subtract the 9 because I have to keep everything balanced. Normally, I would add 9 to both sides, but I can't because I can't add anything to that y side. When I split this here, this is my perfect square. So I have y equals x plus 3 squared. And then I combine these like terms and I get minus 6. And the nice thing about these is there's nothing to solve after that point. That's it. This is our equation. We're just trying to write it in a different form. And then the vertex for this one would be -3, -6. Make sure you don't forget your parentheses around your ordered pairs. A lot of you have been doing that. If all you write is -3, -6, that's just a list of two numbers. It does not represent a point on the graph. You must have the parentheses, and I'm starting to notice lots of you leaving them off. So that's just something to be watching out for. Okay, so that is how we can change a standard form equation into vertex form.